Hello everyone, hope you are doing well. In this video, I will explain about JVM architecture. So this is a JVM architecture. In this video, I will explain JVM architecture consisting of three parts: class loader, subsystem. This class loader subsystem work is to find the .class file and load it into method area. So these are the various runtime areas or memory areas. These memory areas, it will allocate the memory. So after that, execution engine, this will work is to convert the bytecode into machine code. So let's get started. This is not a scratch video, it is continuation video. Java virtual machine JVM playlist. In first video, I am explaining about high level JVM architecture. In second video, current video, I will explain about full architecture of JVM. So let's get started. Open the paint. See, I am drawing the one. Assume this is a JDK, Java Development Kit. So assume this is a JDK. I will write some bullet points. Suppose step 1, a JDK stands for Java Development Kit. It contains it contains R library files and utilities to develop Java program. Utilities to develop Java program. What is JDK? JDK stands for Java Development Kit. It contains all library files and utilities to develop Java program. Right? So this is the JDK. Next point B. There is no JRE. There is no JRE Java 9 version onwards. Remember, there is no JRE Java 9 version onwards. So suppose this is the JDK, right? JDK Java Development Kit, all library files and utilities to develop Java software, right? So inside B for Java 8, we have the JRE and JVM, right? JRE and JVM 2 are there. But after Java 9 version only, yeah, JVM only there. There is no JRE. JRE is not there. So JDK stands for Java Development Kit. It contains all library files and utilities to develop Java program. This is understand, right? There is no JRE Java 9 version onwards. JRE is not there. So step 2. So actually, what is JRE? I will also add one point about JRE as well. Third point, JRE is Java Runtime Environment. Java Runtime Environment. Java Runtime Environment setup provided for to run the Java program. Here JRE is you can also mention JRE stands for Java Runtime Environment setup provided for to run the Java program provided to run the Java program. JRE stands for Java Runtime Environment setup provided to run the Java program, right? Java 9 version onwards, this JRE concept, JRE is removed from the JDK. JDK inside JRE there, right? See, this is JDK inside JRE will be there. Actually, see, this is JDK, right? JDK inside JRE will be there. JRE inside another box, JVM will be there. JVM will be there, but this JRE removed. So The JRE removed. Now inside JDK, JVM only there. JVM only there, right? JDK. What is JDK? JDK stands for Java Development Kit, comma, it contains all library files and utilities to develop Java software. Utilities to develop Java software. Java software. See, JDK stands for Java Development Kit, comma, it contains all library files and utilities to develop Java software. There is no JRE Java 9 version onwards. So JRE stands for Java Runtime Environment setup provided to run the Java program. Right? Second step, we are understand that JDK. What is JVM? Let's understand the JVM. First point, JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. Java Virtual Machine. Second point, JVM is part of JDK. See, JVM is part of JDK. JDK is there inside JDK. JVM is there. So JVM is part of JDK, right? JVM is a process based virtual machine. Is a process based virtual machine. JVM is a process based virtual machine, right? The JVM JVM has the responsibility to search find, comma, load, comma, allocate memory and execute the Java dot class line by line. See? JVM stands for Java Virtual Machine. Java Virtual Machine. JVM is part of JDK. JVM is process-based virtual machine. JVM has the responsibility to search, comma, find, comma, load, comma, allocate memory. Here, first it will search for the dot class file. If find, it will search. If find, it will be loaded into method area. Then it will allocate the memory for the different areas like method area, stack area, Java stacks, PC register, native method stacks, these, and execute the Java dot class by line by using execution engine. We will execute the Java program by line by line, right? This is the second step. Third step, step 3, A, create one Java class. Create one Java class. You can mention like Java file. Create one Java file. So here, create one Java file. Let's create here. I will write some Java file here. After that, I will copy paste in new file. So example, suppose one example, public class demo. So it is a demo. Here, static and instant variables here. Class level variables are instance variables. So public static int a semicolon, public int b semicolon. After that, create one static block. Static. So inside this block, initialization logic. This static block is loaded at the time of class loading, right? Static block or initialization block. Initialization block. This block executed at the time of class is loading. Remember? So I am assigning b for one value. B is equal to suppose 15 semicolon. After that, I am using this is the static, right? A is a static variable, right? First you can use static one, a equal to 15. After that, your system dot out dot println. System is a class, inside one variable is there, out. It is written in the print stream. In the print stream, it is a one method. So some message static block static block colon plus a. This is the static block run, right? You can add instance block, non-static block, or you can use non-static block. So non-static block when it will be called when object will be created, right? See, this is the static block. This is the non-static block. Non-static block are instance initialization block. This will be executed when we will create the object. That time only this will be invoked or called. So right here add b is equal to suppose b is equal to 22 semicolon. You can use system.out.println. Same copy this one, paste here, change to do one thing. You can just change to non-static block B. Right? This is the done. So take one main method. Add one main method. Public static void main string args. So main method added, right? Create another variable like c. So int c equal to 20. So about 20. Next, create the object. Class name is a demo, right? By using class name, I want to create a object. Demo colon new demo of this is the constructor. It is a new keyword. This will allocate the memory, right? So you can use system.out.println. This one you can use system.out.println. Here system.out.println demo object. You can mention like a demo object. Just you can call demo.b. This is a b is a non-static variable. We cannot call it. Is not possible to call with directly with class name. Like this is a static variable, right? We can able to call by using class name. Class name dot variable name or class name dot method name. If method is static, right? Here non-static. B is a non-static variable, so I am calling with the object reference. This is the reference variable. You can also recommended to take class name with R lowercase. R lowercase. Next, this is the done, right? Create another object. Create another object. So I am giving like demo one. Demo one. Let's do here. This is demo one, right? Demo one dot B. I am initializing to this one, this value I am passing to B. So this is the I am pass equal to C. Here what we are doing, so this is the B is the integer value, right? So this C integer value assigning to B. That's it. You can demo one. This is done, right? So create one method. So create one method, scroll down here, public string. So I'm creating public static string get data. Some dummy method I'm passing string some name. So I'm returning the same return name. Some name I'm returning here. Method call here. Method call support. I will add another method as well. So this is static method, right? So demo dot method name get data. I'm passing my name. So this is done. It will return the string. Return type is string, right? This is return type string. String name equal to, you can use system.out.println to print the name. System.out.println of name semicolon. It is done. So create another method. So this method we are created it. So create another method as well. Here create non-static method public string get here get data, right? Suppose get value. Suppose get value. You can take string value. These are the dummy methods. So return value. So this value I'm passing as a string type, right? After that, you can call like here you can call. I need an object to call, right? I am using now demo one. I will use this demo one to call demo one dot get value. Get value. Suppose I am passing 10. I am passing 10 string. Suppose value equal to I want to print system dot out dot println of value, right? This is done. So I want to add one native method. Native methods are implemented in C, C++, etc. programming languages. These we are reusing into our Java programming language. We are just providing here declarations only. Implementations are there in native languages. Native languages are nothing but C, C++, etc. For example, sleep method, wait method are the implemented in native languages, but we are using, that's it. So public native, this is a native method. Native methods are implemented in C, C++, these languages. Public native int sleep semicolon. So that's it. Just copy this code. Just copy this code. Let's try to compile it. So we are added. Another bracket is missing. So let's check. This is the main method. So this one, got this. So we add last, right? Copy this code. Create one demo Java file. Control C. I will create one folder here. Right click new. I will mention like JVM. So right click new. Test document. Open it. Management. Control V. Control S. File save as public class, right? This is demo.java. So close this one. See, demo.java file will be created, right? Now next point, this is B. Yeah, post A point is where added. This is B1. So B. Suppose step 3 column, right? Okay. B point. Now we have dot Java file. Now we have dot Java file, right? So recheck what is the name of this file? Demo.java. We have the demo.java file. So let's see third point. Open cmd in the current location of dot Java file. Java file available. Java file. Java file. Java file and the open cmd in the current location of dot Java file. Java file. must in this location dot java file will be available. So will be available, and let's check in this location dot java file is available, right? So open cmd. Must java is installed in your system. Let's check java. See java hyphen version. Java hyphen version. See it is 17 is there. Clear. So after that compare a java file. Compare a java file by using the java compiler. So example like java c class name.java, right? Compile a java file by using the java compiler, java c space class name. Here in our case, assume this is the cmd. So java c space demo.java. So enter java c space demo.java c space demo.java. See here, we need to observe. See in this location, as of now, two files are there. One is the text file, one is the demo.java file, right? Now I am comparing Java program by using Java C space demo.java. So let's observe in this folder. I am entering. If any errors are there, it will show. See, this showing error. So let's open this. Let's try to open with Notepad. So this is the missed another error. Let's check. This is the one error. Illegal start of the expression. So 31. Let's check 31. So let's check the error. Public static void main string args. Let's again compare. Observe this here. Only two files are there. Let's check if any errors are there. I will solve again. So it is showing again. So save the file. Control S. After that, run again. Yeah, run again. Java space demo.java. Let's check in directory. JVM directory. I'm entering. See, two errors are there. Illegal start expression. Error. So, is there any possibility number? Let's check numbers. So public class demo. These are the two. Static block. After that, instance block. Next main method. Public static void main string args. So this is the right. This is the right. Is fine. These two are the method call. It is fine. So cut this one. Control X. Here I add this. This is the main method, right? Control S. So let's again run. Close this one. Java C space demo.java, enter. Observe, it will be created. See, one demo.class file will be created, right? Demo.class file will be created. So add another point here. Another point. This is the third point, right? Add fourth point. Fourth point here. Take another step. Step 4. Step 4. A after Java file compilation. After Java file compilation, observe one dot class file will be generated in current current location of dot java file. Here it is most important. After Java file compilation by using we are done, right? Here Java C space demo.java. After running this Java compilation command, after Java file compilation, observe one dot class file will be generated in current location of dot class file. Right? See, observe, this is the Java file is there, demo.java. In this file, after running Java C space demo.java, one class file will be generated. Right? This is the important point. Remember. After that, B here Java compiler, Java compiler, Java C is responsible to generate the bytecode. Java space compiler, Java space compiler. This is Java C, right? Responsible to is responsible to generate bytecode. After that, bytecode. So add another point here. Suppose this is a B. Now we have the demo dot class file. Now we have the now now we have the demo dot class file, right? Demo dot class file. So the compiler, Java compiler, Java C is responsibility to generate the bytecode. Java compiler, Java C is responsibility to generate the bytecode. Third point, third point here. So this is the third point. This is the fourth point. Fourth point. Whenever 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 we are executing Java class JVM will take dot class file as input. Dot class file as input. This is important. So some space here. Scroll down. Next step 5. See, after Java file compilation, observe one dot class file will be generated in current location of dot class file. Now we have the demo dot class file. Now we have the demo dot class file. Java compiler Java C is responsibility to generate bytecode. Is responsibility to generate bytecode. Whenever we are executing Java class, JVM will take dot class file as input. Take dot class file as input. Let's observe what is there in inside dot class file. It is saying like a bytecode, bytecode generated. Java compiler, Java is responsibility to generate bytecode, right? What is there inside bytecode? Right click, open with. Let's check if there any option open with. Open with. So do one thing, right click, open with edit plus. Let's see what is there in inside dot class file. Oh, what is this? So this is showing like bytecode. So bytecode is not able to understand. Remember, this is the bytecode. See, it is a bytecode. So this bytecode, humans are not understandable. So this is a bytecode. This is a binary code. Remember, simply this is a unreadable format, binary format. So see, this is the unreadable format or binary format. So I am closing this one. So next, whenever we are executing Java class, JVM will take dot class file as input, right? So step 5 in A, run run or execute dot class file class file JVM starts from here. JVM starts from here. It is very, very important. Run or execute dot class file, comma, JVM starts from here. JVM starts from here. So command to execute the Java program. Run or execute the Java program. Java space class name. Here class is a demo, right? So it is important. Run or execute dot class file, comma, JVM starts from here. This is the command. So next step 6. So let's run the Java space demo. After running this command, what will happen? See here, run or execute dot class file. JVM starts from here. Then JVM will be started. JVM will be started. That's it. First we are added, right? JVM about JVM stands for Java Virtual Mission. JVM is part of JDK. Is the process-based virtual mission. This is the important. See, JVM has the responsibility to search, find, load, allocate memory, and execute the Java dot class file line by line. JVM has the responsibility to search, find, load, allocate memory, and execute the Java dot class file line by line. So it is important point. Remember. So let's run the. It will do search, load, allocate memory, and finally it will execute the Java file, right? It will execute the at last it will execute the mission understandable code. Now we are converted to Java class to binary format. After that, this will be converted into mission code. Then mission code understandable, right? Execution engine will execute the mission code. So run or execute dot class file. This is the command to execute the Java file, Java space demo. Then what will happen here? See, JVM starts from here. JVM starts from here. So I am entering. Enter. See, after entering, this is the response I am getting because some system.out.println blocks are there, right? System.out.println. These some these are the added, right? System.out.println. So these are the displaying, these are printing some values. So that's I am done, right? Java space demo. So JVM is started. After JVM will started, what will happen? Let's I will draw, I will use now one word by using the draw.io. Draw.io. This I will use to draw the diagram. So let's wait. Cancel. So first I will add the point 6 point here. JVM will be created with various runtime or memory areas. Runtime or memory areas. Memory area. This is important. After running the Java space demo command, JVM will be started. JVM starts from here, right? So after JVM started, the JVM will be created with various runtime or method runtime or memory area. See, after JVM starts from here, after starting the JVM will be created with various runtime or memory areas, various runtime or memory areas, runtime or memory areas. So they are five. They are five. They are five. One is method area. Method area. Method area. Inside method area, meta space will be there. Meta space will be there, and runtime constant pool will be there. Runtime constant pool. Runtime constant pool will be there. I will explain one by one later. Method area. See, method area, meta space will be there. Runtime constant pool. Method area used for the load. Once dot class file will be available, then it will load it into method area. Once dot class file will be available, then dot class file will be loaded into method area by using class object. By using class object, I will explain in this video. Later on, I will explain more about method area. So next, heap area. Heap area. Objects will be created. Third one, Java stacks. Here method calls will be there. Logics will be executed. Method calls will be there. PC registers. PC registers. PC means PC stands for PC registers, right? PC PC stands for program program counter program counter. It is one per thread. So each is one per thread. Current thread instructions to be executed. PC registers. PC registers. PC stands for program counter. It is one per thread. Each thread instructions to be executed. So next, fifth, negative method stacks. Negative method negative method stacks. This work to execute the negative methods like sleep method, wait method. This work to execute the negative methods. Negative methods. So the three for the one for the thread. The three for the one for the thread. The two for the one for JVM. One for JVM. So if one for JVM. These two for the one for JVM. Here the three for the one per thread. One per thread. One per thread. One per thread. These are the one per thread, right? So step 7. First draw the diagram. The JVM will be created with various runtime or memory areas. JVM will be created with various runtime or memory areas. There are 5. The two for one for JVM. Java virtual method area. In method area, method space will be there. Runtime constant pool will be there. Heap area, method area. After class loader subsystem, finding the dot class file, it will be loaded. Then heap area. Heap area will be objects will be created, right? This is one per thread. Java stacks. PC registers. PC stands for program counter. Native method stacks. Native method stacks nothing but native method. These methods are implemented in C, C++, etc. languages. Like example, sleep, wait. These are the implementations available in native languages, but we are using. See how we are declaring. See, this is the public native into sleep native method. This is the native method, right? So let's draw the diagram up to this 6 point. JVM starts from here. So, so I will use both notepad, this paint and draw.io. So wherever possibility is there, I will use paint, and wherever possibility is there, I will use draw.io. So I am copying, Control C, paste here, Control V. So this is the JDK, under JDK JVM will be there, right? So keep it here. So let's add the JVM. So about JVM will be created, right? So here, so JVM will be created. Increase the size. Okay, fine. This is the JVM. So let's check it is editable or not. Okay, fine. It is editable. So see, JVM will be created with runtime, with various runtime or memory areas. There are 5. So we need to add 5 boxes. So 5 boxes, right? 1, 2, 3, 4, 5. We need a 5 boxes. So these are the 5 boxes. So let's add. These are the 5 boxes, right? So this is the JDK. Let's see, I will also add this dot Java file, dot class files, where these files are there in. So see, it is a C drive. So nothing but it is a hard disk. So these are the hard disk. Inside hard disk, these files are there. So let's add the one hard disk. Suppose, so let's add the one hard disk. Suppose it is a hard disk. So add the name text hard disk. So increase the size to 20. 20 is sufficient hard disk. So inside hard disk, see inside hard disk only, right? Java I am downloaded from internet, right? See, open JDK. See, this is the open JDK. It is a Java software. It is there in D drive, right? It is a hard disk. So inside hard disk, inside hard disk, JDK will be there, right? So JDK will be there. Increase size to 20. Suppose I am adding here. This is the hard disk. Inside hard disk, JDK will be there. So by using JDK library, I am developing the Java file and I am executing. So let's first by using Java library, I am developed one demo.java class. Java class I am developed by using the library, right? By using Java library, this file I am generated. After that, so I am compiled this class by using compare by using Java C demo.java. I am compare this file. So increase to 20. So by using Java-C, this file I am compiled. So this is compiled, right? After compilation, it is generated one dot class file. Demo dot class file will be generated, right? So this file will be generated. This file will be generated. So after that, I want to execute the Java file. For that, next run execute. Suppose execute command is Java space demo. So increase the font 20. Right. See in hard disk, JDK will be there. Inside JDK will be there by using JDK commands like Java C. These library files and these are the commands. I am developed Java file. After that I am compiled. After compilation dot class file will be generated. After that I am executed by using Java space demo command. So this is done, right? So let's add the link between. So see this is the JDK, right? So JDK do one thing. Suppose this is the JDK inside JVM. I'm writing separately this diagram. Suppose for arrow mark, suppose you can add like this, right? See, class loader subsystem contains three parts, right? First one is the loading, linking, initialization. As of now, loading was completed, linking and initialization is pending, right? So once dot class file will be found, then it will be goes to method area dot class file loaded class level metadata information by using class dot for name dot class file will be loaded, right? See here, step number, if dot class file found, then loaded into method area, then dot class file loaded and class object will be created to represent total dot class file information and dot class code stored inside class object, right? By using class dot for now we are loading the dot class file, right? Next here AB, this is the C. Let's add the D. So D for every for every loaded dot class file have only one class object. Only one class object will be created. Will be created even though we are using demo class object multiple times in our application so here do one change here. This is the class name, right? Our class name can mention our class name. See, for every loaded dot class file have only one class object will be created, even though we are using our class object our our class object multiple times in our application. It is important for every loaded dot class file. See, one dot class file will be loaded. Example, demo dot class file, it will be loaded by using class instance, right? So every loaded dot class file have only one class object will be created, right? One object will be created, even though we are using our class object multiple times in our application. So I will show, let's example. I will create one example here. So I will write one example. Let's remove this code. Remove this code. Suppose this class is there, right? Test 1, 2, 3. So after that, you can add like a T1 equal to new class name. It is the one, right? So you can T1 dot get class. See, get class written in class colon. Get class semicolon. You can use class colon of. You can mention like class object C1, right? You can create another T2 C2. You can mention this is T2. Then compare these two. System.out.println. Here C1 dot as code. C1 dot as code. C2 dot as code. And system.out.println S4 system.out.println C1 double equal to C2. Control S here. See, for every loaded dot class file have only one class object will be created, even though we are using our class object multiple times in our application. So it is a one class is there. For this class I am created multiple object, two object. See, I am saying here, for every loaded dot class file have only one class object will be created. Only one class object will be created, even though we are using our class object multiple times. So these are the class and created multiple objects, even though we have only single class. Then see, we will get both are true. Let's see what will happen. Right click, run as Java application or Spring Boot app. See, both as codes are same and true. Right? So copy this one, Control C, paste here, paste here. Paste here. After that, you can add, this is example, right? You can add dot class file loaded only once and class object created only once class object created only once. It is important. Dot class file loaded only once and class object created only once. So now next point. See, I will repeat. If dot class file found, then loaded into method area, then dot class file loaded and class object will be created to represent dot class file information, right? Dot class file information and dot class code stored inside class object dot class dot for name. This is the package name dot class name. So example, class dot for name demo dot class. For every loaded dot class file, we have only one class object will be created, even though we are using our class object multiple times in our application. So example, dot class file loaded only once and class object created only once. This is the code done, right? Next one, when dot class file loaded, it is very important. When dot class file loaded into method area, method area, then default thread also loaded, loaded and created in Java stacks, PC register, PC program counter, PC register, register, negative method, negative method area, negative method negative method area. Here it is important. When dot class file loaded into method area, then default thread also loaded and created in Java stacks, PC registers, PC register, negative method area, negative method area. So let's draw the diagram as per this. When dot class file loaded into method area, then default thread also loaded and created in Java stacks, PC register, native method area. So copy this one. It is not editable. So do one thing. Control X. Control X. You can add default threads. Default thread. Perfect. We need to copy paste this in 3 places. Control C. See here. Day 3. Java stacks, program counter register and native method stacks are one pair thread, right? One pair thread. Day 3 are one pair thread. So one thread will be created. So one thread will be created. Right? This is done. Next point. So step. This is not here. This is done. 14. If dot class file not found in any of class loaders, inner class, then class loader inner class will throw error like class not found exception, right? Class loader subsystem contains 3 parts. They are loading, such as for dot class file. If found, then loaded into method area, linking and initialization. 3 parts, right? Loading, linking and initialization, right? So let's add some discussion about loading. So loading, first one is loading, right? Here observe, go to loading. These are the class loader subsystem, 3 types, right? Loading, linking and initialization. Here loading contains class loaders are there, right? Bootstrap class loader, extension class loader, application class loader. If not suitable, this so custom class loader. So let's add here loading contains 3 are the Java is given. Suppose 3 plus 1, 3 plus suppose star custom loaders. If multiple. So loading contains 3 dot star means any types of class loaders to search dot class file in different types of locations, and if found loaded into method area, if found loaded into method area. See, it is important. Loading contains 3 Java is given plus star means our choice, our custom class loader. If multiple. In this video, I am created one. Loading contains 3 types of class loaders. If any user defines, then you can add types of class loaders to search dot class file in different types of locations, and and if found and if found and if found loaded into method area. Loading contains three types of class loaders to such dot classified in different types of locations if found loaded into method area. This is done by see, once loading is completed, then request it is going to linking, right? Next step 16. Step 16 here. Once loading was completed, once loading was completed, comma, then request goes to linking, goes to linking. Here once loading was completed, comma, then request goes to linking, request goes to linking. Step 17. See, once loading is done, right? So this is loading is done. Dot class file found. We are loaded into method area. While loading method area. So in stack area, in Java stacks, program counter register, negative method stacks, default thread also loaded. So now it is moving to next stage. Here class loader to it goes to class loader. It goes to inner classes. Inner classes class loader subsystem. We can also call it as class loader subsystem. It is loading. It is loading by using delegation hierarchy algorithm. It is nothing but delegation hierarchy algorithm, nothing but first it will give priority to burst of class loader to such. If not found, it will give again platform class loader to such dot class file. If not found, then it will give application class loader to such dot class file. If not found, custom class loader. If not found, then the exception will be raised like class not found exception, right? This is done now. Linking. Now we are linking. So these are the connection are there. Yeah, this one. So yeah, this one. Yes, this is the one connection will be there. So you can also add. This is also initialization. This is also connection will be there. This is also connection will be there. See, once loading was completed, then request goes to linking. Linking content three parts. They are. This is linking. Linking. Linking contains three parts. Linking contains three parts. They are linking contains three parts. They are a verification. These are the important verification. Verification. Another one preparation. Preparation. Verification. Preparation. Another one is the resolution. Resolution. Verification. Preparation and resolution. Linking contains three parts. Verification, preparation, resolution. Resolution, right? So I will explain one by one. Linking contains three parts. They are verification, preparation, resolution. So let's add the three. Verification. Verification, right? So text verification. So font size 20. First one verification. Second one preparation. Second one is the preparation. So second one is preparation. Third one. Third one is let's check resolution. Third one is resolution. So select bold size pixels 20 px. Pixels 20 px. Then here next step 18. Step 18. Here now first one verification. Verification. Verification, right? In verification, first point A bytecode verifying valid or not. Bytecode verifying valid or not. Bytecode verifying valid or not. Valid or not. Second one whether dot class file is whether dot class file is structurally structurally correct or not, structurally correct or not. Check the spelling. S STRU, structurally structurally correct or not, properly formatted or not, properly formatted or not, properly formatted or not. Is it generated by valid compiler or not, compiler or not. See, link verification. In linking contain three parts: verification, preparation, and resolution. Verification, bytecode verifying valid or not, whether dot class file is structurally correct or not, properly formatted or not, is it generated by valid compiler or not. So, step 19, preparation, 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 preparation. Understand, right? Verification, bytecode, verifying valid or not, valid or not. Control C. I copied. I will add here. So, text. So, increase to 15. Increase to 18. Subsequent. You can add like this. Verifying is nothing bytecode, verifying valid or not. So, whether dot class file is structurally correct or not, properly formatted or not, is it generated by valid compiler or not. So, preparation. Before going to preparation, I will show. So, bytecode verifying valid or not. How to verify bytecode? I will show. See, this is JVM, right? This is dot class, nothing but bytecode, right? Binary format, right? So, open with edit plus, this is the code. Do one thing. So, I'm decided to remove here. I removed some code. Control S. I saved. So I will try to execute. See here, previously output this. I will try to execute. Don't compare. If you compare, it will generate again bytecode. So just run. After comparing, bytecode will be generated. That code I modified. Let's see Java space demo. See, class format error. Class format error. Unknown constant tag in class file. See, error we are getting. Read once. Whether dot class file is structurally correct or not, comma, properly formatted or not, comma, is it generated by valid compiler or not. This is done, right? Preparation. Preparation. Here, 19 step preparation. Allocate memory for class level static variables, along with along with default values, in method area, method method area, but not original values, original but not original values. Here, allocate memory for class level static variables along with default values in method area, but not original values, Let's check what are the. Here, go to open this class, edit. Let's check what are the static variables. See, static int a. This is a is there, right? So what is saying here? So allocate memory for class level static variables along with default values, in method area, This work to allocate memory for class level static variables along with default values in method area. So this is done. So let's add. So go to post method area. So this is method area. We have the static variable, right? A equal to 0. Suppose a equal to 0 semicolon. So increase size to 20. So here this is the static variable. It is initialized with 0, right? So goes to CR preparation allocate memory for class level static variables along with default values in method area. This preparation will allocate here memory for static variables. Allocate memory for static variables. So what it will do? Text allocate memory for static variables with default values. Allocate 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 memory for static variables with default values. So increase size to 18. So let's move to this preparation. Here preparation. Move to preparation. Now preparation is done. Here allocate memory for static variables with default values. Preparation will do next resolution. So it is done, right? Step 20. Step 20 resolution. The next one resolution. So in this resolution, it is the three under. This is the verification, preparation, resolution under the linking. Right? So linking content three part there: verification, preparation, and resolution. So here all symbolic, all symbolic, all symbolic, all symbolic representations are representations replaced with original references. In this resolution, all symbolic representations replaced with original 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 references. All symbolic representations replaced with original references. Symbols symbols stored in constant pool. Symbols stored in constant pool. Example as one. Here resolution all symbolic representations replaced with original references. Symbols stored in constant pool. So let's use Java P space hyphen verbose our class name demo right 2C complete bytecode 2C complete bytecode. Step 21. See, step 20 resolution all symbolic representations replaced with original references. All symbolic representations replaced with original references. Symbols stored in constant pool. Example as one by using 2C complete bytecode. Java P hyphen verbose demo. Let's check this one. Control C rerun Java C hyphen demo Java demo. So Java P hyphen verbose demo. Enter. Here this is complete bytecode. The bootstrap methods. It is a bootstrap class loader, right? Let's check from the top. Here we are run the Java hyphen verbose demo. This command. So after that, last modified date is printing. After that, some check something is there. Compiler from this is the class name. So it is started demo, minor version, major version, flag. These are here. This is the important constant pool. These are the as 2, 4, 5, 6. These are the some numbers are given. Next, see like this. So here public static int a, this is the variable, some descriptor flags, this like that. So see, important line numbers as well given. So scroll up. So here constant pole. See, resolution, all symbolic representations replaced with original references, all symbolic representations replaced with original references, symbols stored in constant pool. See, symbols constant in symbols stored in constant pool. Example, as1, as2, as3, etc. 2C, complete bytecode use Java P, verbose, space demo, all symbolic representations replaced with original references, right? Control C. So let's add. This is the resolution. Now it is last one. Resolution in linking page. Resolution. So select all. Increase to 20. This is the size 16 only. So change to 16, 18. See, all symbolic representations replaced with original references. Original references. See here, linking. Linking contain three parts. Verification. Linking contain three parts. First one, verification. Bytecode verifying valid or not. Preparation, allocate memory for static variables with default values. Static variables with default values. Resolution, all symbolic representations replaced with original references. All symbolic representations replaced with original references. So let's move to initialization. Next move to initialization page. Class loader subsystem three types. Three parts are there: loading, linking, and initialization. Loading is done. Loading three types, that is done. Linking three types, that is done. Initialization, now we are in initialization phase. Initialization, in initialization phase, here it is a initialization. So verification, preparation, resolution. This is done, right? In class loader subsystem three types: loading, linking, initialization. This is the initialization phase. Now it is the initialization phase. Here in initialization phase, all all static all static variables will be assigned. All static all static variables will be will be assigned with original values and static blocks will be executed from top to from top to bottom, and from parent to child. See, all static variables will be assigned with original values, and all static blocks will be executed from top to bottom, and from parent to child. Initialization, all static variables will be assigned with original values, and all static blocks will be executed from top to bottom, and from parent to child. Copy this one. So new text, select all, bold, pixels to 18. So here all static variables will be assigned with original values. So original values, let's see, this is the static variable, right? Let's check in console. CLS clear. Java demo. So static block value is the 15, right? So it will be static blocks will be replaced with static variables will be replaced with original values, right? Here, see, See, all static variables will be assigned with original values. Original values, right? So use control Z, control cut. Here a equal to 0. This is the a equal to 0, right? So cross. So now it is the value is 15. Value is 15, right? Value is 15. 15. So copy, go to here, control V, paste. So static variables will be same. All static variables will be assigned with original values, and all static blocks will be executed from top to bottom, from parent to child. So static blocks will be executed, right? Suppose like you can add some message like static blocks, right? Static blocks will be executed. Static blocks will be executed. Static blocks will be executed. Where the static blocks will be executed? All static variables will be assigned with default values, and static blocks will be executed from top to bottom, from parent to child, from parent. Here, static blocks will be executed. Static blocks will be executed. Okay, this is done at here. So control Z, bold 18. Static blocks will be executed from top to bottom, from top to bottom. So here static blocks will be executed from top to bottom, right? So here initialization done. In initialization, static variables will be replaced with original values, and static blocks will be executed from top to bottom, from parent to child. So this is done. Go to diagram. This is done. As of now, we are done. Class loader subsystem done. Next one, these are the areas, runtime areas are memory areas. See, expose here, download. Let's see this email. See, as of now, we are done. Various runtime areas are memory areas. This is done. Class loader subsystem run. Another part is there. Execution engine. JVM architecture is three parts. Class loader subsystem. Various runtime areas are memory areas. Execution engine. So let's add another point. Then step number 22. JVM architecture. JVM architecture consists of three parts. One is class loader subsystem, class loader subsystem. The second one is various memory areas are various runtime areas are memory areas. Various runtime areas are memory areas. Third one is execution engine. Execution engine. Step 23. In step 23, I will discuss about execution engine. Close this one. So let's, two parts are done, right? Third part is pending. Let's draw a diagram for execution engine. So execution engine is pending. So expand this. These are the memory areas, right? In top, we need to add class loader subsystem as well. So we need some more space top. So bigger size, better to use like this. Yes, this is the one. Move this first, second one. Yes, this is the second one. This is the third one. Yes, fine. So this is the fourth one. Fourth one is a PC register. PC stands for program counter, right? This is the fifth one. So expand. Yeah, okay. First one, let's check name. First one is the method area, app area. Next one. First one is the method area, right? So add one text box. Add at top. JVM scroll down. This is the method area. What is this? This is method area. So bold, increase to 20. So this is method area. Expand up to this one. This right next. This is the app area. So text app area. This is the app area, right? Select this bold 20. This is the file. Yes, right. Next one. Third one. Java stacks. See, this is the Java stacks. One per thread here. Objects will be created. See, Java stacks here. Method calls will be there. Logics will be executed, right? So method area. Dot class will be loaded. Meta space. Nothing but meta space. After that, heap area objects will be created. Java stacks. Java stacks nothing but method calls will be there. Logics will be executed, right? Third one, Java stacks. So see, third one, Java stacks. Java stacks. Size bold size 20. So expand this. This is done. After that, PC register program counter. Here PAC stands for program counter register. So add text program counter register, right? So 20. This is the program counter register, right? After that, this is the last one. Native method stacks. So native method stacks. These methods are implemented in native languages like C, C++, etc. Native method stacks. So native method stacks. So these are there inside the JVM. These are the memory areas, right? These are the memory areas. So add here various memory areas are runtime areas. So various memory, various memory areas are runtime various runtime areas, runtime areas. Same size, same bold, 20. Otherwise, if you want, you can also increase. Better to increase. So 30. Various memory areas are runtime areas, right? So here adding. Then these are the memory areas there in JVM, right? So add one box. So scroll down, add one box. So yes. So next add these are the 5 memory areas in JVM. So I am adding in like a one box kind of. So scroll down. So yes, these are the JVM. Various runtime, various memory areas are runtime areas are ready, right? Various memory areas are runtime areas are ready, right? So if you want to reverse, you can also add Control S X. Various runtime areas are memory areas. Various runtime areas are memory areas. Now move this to the center. Yes, let's check. Now we are in this seventh step. So JVM starts from where JVM is started. JVM will be created with various runtime or memory areas. They are five. So one per JVM. These two for the one per JVM. Method area and heap area one per JVM. This is the one per thread. These three for the one per thread. Java stacks, PC register, native method stacks one per thread. So let's scroll down, scroll up. So some space I'm giving here. If any comments I need to add, then it is better to some space. So okay, scroll down. First two are the method area and heap area, one for JVM, right? So accordingly, control that. These two one for thread. So text one per JVM. These two are one per JVM. Bold, font size 20. So these two are for one per thread, one per JVM. These two are one per JVM, right? Yes. So take another one. These three are one per thread, one per thread. So these three are one per thread. So add the command one per thread, one per thread. So bold increase size to 20. Right. See method area. It will be dot class file. It will be loaded here. It is one per JVM, one per JVM. If area objects will be created. It is one per the JVM. Multiple operations will be do like if area will be do objects will be created. Another some operations will be do. I will explain later. So major work method area dot class file will be loaded. If area objects will be created. Java stacks method calls PC registers one per thread PC registers PC stands for program counter one per thread is execute the instructions each thread instructions native method call it will call the native methods these methods implemented in native languages like C++ etc. In Java like sleep wait we can declare these methods like public native int sleep. There is no implementations in Java. Implementations are there in C++ languages. So that seventh point JVM JVM first will such as for dot class file in method area. So assume like it is a JVM first will such as for dot class file in method area. Suppose here this is method area, right? This is method area. JVM will such as dot class file. Here JVM JVM post will such as for dot class file in method area. JVM post such as dot class file from method area. Suppose if it is found. Suppose if it is found. Suppose it is found. It is already there in here. Dot class file demo.java. It is already there. This class file already there. So JVM post will search as for dot class file in method area. Method area. If it is found, then suppose if if found are if found are available, if found are available, then what will happen? If already if already available 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 if already available, then dot class file loaded already loaded and class 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 object will be created to represent represent total dot class information total dot class information and dot class code stored inside class object. I will explain this point here. Suppose assume this is a D class dot for name of. So here package name dot package name dot package. By using class dot for name it will be loaded our class like class dot for name of for demo class there is no package demo dot java. demo.class, demo.class. Here, this is the important point. JVM post. JVM post will searches for .class file in method area. Method area. If one, if available, if already available, then .class file loaded, loaded, and class object will be created, created. So see method area. In method area, .class file will be loaded, right? So I will add one point here. So .class file, .class file will .class file loaded, .class file loaded. So remember this point, loaded, .class file loaded, right? File loaded. Remember this point, .class file loaded, loaded, right? In method area, .class files will be loaded. So now we have one class file, .class file loaded. So see, JVM post will searches for .class file in method area. If one, if available, if already available, then .class file loaded, already loaded, and class object will be created, already created to represent total .class file information or metadata information, data about data, metadata information or class code stored inside class object, class object by using class.forName. Here by using class.forName, for name, this demo class will be loaded into method area by using class.forName. By using this class.forName, this demo class will be loaded into method area, right? So in method area, we are storing, we are loading, not storing. In method area, .class file loaded. Method in method area, .class file loaded. Remember, in method area, .class file, .class file loaded. See, .class file loaded. You can also say class level data, class level metadata. You can also mention like next line if you want to add class level metadata. Both are same. Either you can say .class file loaded or class level metadata, right? So it is done. So next, check here. Here it is important. JVM post will searches for .class file in method area. If found, if available, if already available, then .class file loaded and class object will be created to represent total .class information or class level information or class level metadata and .class code stored inside class object. So by using class for name, our .class file will be loaded. So next. Step 8. So you can either keep it like class file loaded, class level metadata, class level information also fine. So next point here. So post draw the class instance. Suppose it is a class instance. Suppose it is a class instance. So here text demo.class. This is a class instance. So demo class. So so copy this one, copy as email, paste in notepad, paste. Control Z, do one thing. This is the one box. This is a demo dot class. Demo dot class file will be there. So this is the class instance, right? This is the class instance, decrease size to 12, right? Copy this one, Control C, Control V. So see here, 7th point, JVM post will searches for dot class file in method area if found available. See, it is available, it is found, it is available. If already available, then dot class file loaded, already loaded, and class instance, class object will be created. This is a class object already created, class instance, and represent total dot class file information, represents total dot class file information. See, this file total dot class file information here. After created class instance file, this will be loaded, right? Dot class file loaded. In dot class file we have class level metadata or class level information will be there. So class code stored into class object. So see, in method area dot class file will be loaded. Remember, in method area dot class file will be loaded, right? This 8th point. See, in 7th point, where assume like a if found or available. In 8th point, assume like a if not available, if not found, not available. If not found slash not available. If not found, not available. If not found, not available. Then assume it is a. If not found, not available. Then so now JVM will be there in method area. In method area, JVM will be such as demo.class file is already loaded or not. So it is not there in method area. Now what will do? JVM from method area, from method, from method area, from method area, request, request, request goes to class loader to search dot class file, to search dot class file. So it is see from here, from method area request goes to class loader to search dot class file, where it is class loader. Let's add class loader. So draw a one box. So assume as of now it is a class loader. Assume it is a class loader. Request is coming to method area to class loader. Class loader to search dot class file, right? Then after what will happen? See, right? So then class loader sends, then so request is coming to class loader, then class loader sends request to class loader sends here, then class loader sends request to class loader subsystem. Class loader subsystem, it sends to class loader subsystem to search to search to search dot class file in various locations by using delegation hierarchy algorithm. Delegation hierarchy algorithm. Hierarchy algorithm. See, it is important. I am repeating one more time. So if dot class file not available in method area, then JVM, then from method area JVM request goes to, then sends request. If not found, not available, from method area request goes to goes to class loader to search dot class file, right? So for that I'm added this is like a class loader. So after that, then class loader sends request to class loader subsystem to search dot class file in various locations by using delegation hierarchy algorithm. Then class loader sends request to class loader, class loader, class loader types, class loader implementations to such like change to. Then class loader sends request to from method area. Request goes to class loader search dot class file. Then class loader sends request to class loader subsystem. Class loader types to search dot class file in various locations by using delegation hierarchy algorithm. Otherwise, do one thing here. Then class loader sends request to class loader subsystem to search dot class file in various locations by using delegation hierarchy algorithm. Right? Let's draw the diagram. See here. Here, then class loader sends request to class loader types to search types. IMPLs are there, implementations are there. Then class loader sends request to class loader types to search dot class file in various locations by using delegation hierarchy algorithm. Then here diagram. Assume this is a class loader. So class loader add another box. It is a class loader subsys. This is a class loader types. These are the types. So request coming to here. Assume this is a class loader. I'm adding class loader. So size 20. This is the class loader, right? So this is the class loader. Class loader from main from method area request goes to class loader. Class loader request sends to class loader types to such dot class file in such dot class file in various locations by using delegation hierarchy algorithm, right? So these are the types. So these are the types. So these are the types, right? So it is a super class. These are the inner classes. So these are the inner class. I will add dollar symbol as well. So this is a super class. These are the implementations. Suppose super. This is a super class. These are the subclasses. So dot like this is the super class. These are the inner classes. So post request coming to class loader, then it will send to inner classes, right? So then class loader post from method area request goes to class loader to search dot class file. Then class loader sends request to class loader. Suppose inner classes better to you can add inner 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 classes to search. Inner classes are types to search is better. Then class loader sends request to class loader inner classes to search dot class file in various locations by using delegation hierarchy algorithm. So change here inner classes. Suppose these are the inner classes. Inner classes, right? This is the super class. These are the inner class by using this inner class. So we want to search dot class file in various locations. So by using delegation hierarchy algorithm, right? So add that algorithm here, delegation hierarchy algorithm, right? So for that, take this bar kind of Control C, Control V. You can add here, add the name delegation hierarchy algorithm, right? Delegation hierarchy algorithm. So copy this delegation hierarchy algorithm. This is the one algorithm by using we need to find the dot class file. So So I am arranging like this one by one letter. So I am passing this video. So this is the added one by one character. So bold. If it is not visible, then do one thing. Select again this. So increase the size to 16. It is visible, right? Do one thing. Expand this. So expand. Add this. Derivation. Hierarchy algorithm. So expand. Yeah, see. So this is the JVM. Here, this is a outer class. These are the inner classes, right? So let's add another outer class. Outer class, right? Correct. Bold. Font size 20. This is the outer class. So add this one. Yes. Another. This is the outer class. These are the inner classes. I will add this. So do here. Delegation hierarchy algorithm. So right. This is the outer class. This is the inner class. So this symbol, by using this symbol, we can represent the outer class and inner class. Let's add another point. So yeah, let's add fourth point. Add separate point like ninth one. Step 9. See, class loader. Class loader is a outer class. Class loader is a outer class and bootstrapped class loader. Bootstrap class loader, comma, application, bootstrap class loader, comma, platform, 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 class loader, comma, application, class loader, are inner classes represented by $, dollar symbol. See examples, right? This is the class loader, right? Class loader, it is a outer class. Class loader is a outer class dollar. So suppose bootstrap class loader, it is a inner class. Same, copy paste 2 times. Another time. After that, platform class loader. Platform. This is the platform class loader. After that, application class loader. This is the application class loader, right? So this is the application class loader, right? So node point, it is important node point. Node extension class loader. Extension class loader. Remote and in that place platform class loader platform class loader introduced. So if you want to points A, you can add this A. So you can add B. These are the B. So it is a C. C extension class loader removed and in that place platform class loader introduced. Platform class loader introduced. Right? Let's add these names. So post bootstrap class loader, right? This is the inner classes. So increase. Okay. Post one bootstrap class loader. Select bold font size 20. Size will be 20. So yes, fine. This is the bootstrap class loader. After that, platform class loader. I am also adding extension as well. So extension bracket removed. Extension removed. After that, bold 20. Extension class loader. So this is the extension class loader. It is removed. An alternative is platform class loader. After that, application class loader. Now next one, application class loader. Add here. So text control V application class loader. Select this one. So bold size 20, right? Application class loader, right? So the class loader is a outer class and bootstrap class loader, bootstrap class loader, platform class loader, application class loader are inner classes represented by dollar symbol, right? This one node extension class loader removed and in that place platform class loader introduced. Since you can mention like since Java 9 version onwards. You can mention like since Java 9 version onwards. This is done, right? So next. So next step 10. Step 10 delegation hierarchy, algorithm. Algorithm algorithm will delegates delegates request to parent class loader class loader to search dot class file if not found then immediately searches in subclass here 10th step delegation hierarchy algorithm will delegate request to parent class loader to search dot class file. If not found, then immediately searches in subclasses. Right? So I will show order of the priorities. Priority orders. See delegation hierarchy algorithm will delegates request to parent class loader to search dot class file. If not found, then immediately searches in subclasses. Searches in subclass loaders. Delegation hierarchy algorithm will delegate request to parent class loader to search dot class file. If not found, then immediately searches in subclass loaders, right? So here, while searching dot class file, priorities are while while searching dot class file, priorities are priori, priorities are so first priority is to bootstrap class loader, bootstrap class loader, bootstrap class loader. It is highest, highest priority, highest priority. After that, second priority is to platform class loader, platform, platform class loader, platform class loader. So next highest priority, next highest priority, next highest priority, third highest priority is application class loader, application class loader, application class loader. It is the last priority. You can mention like last. You can mention suppose next priority, next priority. So this is important here. Delegation hierarchy algorithm will delegate request to parent class loader to search dot class file. If not found, then immediately searches in subclass file. If it is found, it will be loaded into method area. If not found, then it will immediately searches in subclasses, right? So see, it is a post bootstrap class loader is highest priority, right? Parent class loader is like a bootstrap class loader is a parent class loader. These are the childs. Post priority goes to this one. Then you can add like a parent child kind of. So parent, parent. So increase to 20. It is a parent. It is a parent. So it is a child. So child. So increase to 20. This is the child, right? So next use this one. So add some curve. Control that. So cut this one. Control C. Control V. So post it will delegate to extension class loader. After that again it will delegate to bootstrap class loader, right? So post it will goes to application class loader. It will just sends to extension class loader. Again then it will sends to, so suppose it will come in here. It will then it will goes to, so post it will come to application class loader. It will not like it will not search dot class file in here. Application class loader is just forward to extension class loader. Again it will forward to bootstrap class loader. So if it is in bootstrap class loader, if not found, it will be immediately search in platform class loader. If it is not found, it will search to application class loader. Do one thing. So this is extension class loader, right? So use here. This is a forwarding request, forwarding. You can mention like forward. So size bold increase to 20. Control Z. Select this one. Forward. See, it will forward. Post it will go come to application class loader. It will forward to extension class loader. Then it will forward to bootstrap class loader. Bootstrap class loader. Yeah. select this one, bootstrap class loader. Here, let's read. Delegation hierarchy algorithm will delegate request to parent class loader to such dot class file. If not found, then immediately searches in subclass class loaders. While searching dot class file, priorities are bootstrap class loader, highest priority, next highest priority, platform class loader, next highest priority, application class loader, application class loader, next priority, right? So the class loader is a outer class and bootstrap class loader, bootstrap class loader, platform class loader, and application class loader are inner classes represented by dollar symbol. We can also, I'm adding custom class loader, our choice, custom, custom class loader. If it is not suitable, these class loaders are not suitable our requirement, then we need to add custom class loader. So next will be the custom class loader. So next priority. Suppose mention like last priority. Last priority is a custom class loader. Custom class loader is a last priority, right? So I'm adding this one. So here, so let's add another class loader. This is the custom class loader. Custom class loader. Control Z. Increase to 20. This is a custom class loader. Do one thing. Control Z. Post custom class loader. So next one. This is the platform class loader. Control Z. So next, Control C, Control V, bootstrap class loader. This one is the bootstrap class loader. So if these three class loaders are not suitable, then we need to add custom class loader. Our class extends with this class loader, outer inner class. This is the outer inner class. This is outer class. This is the inner classes, right? Outer class extends our class. It is nothing but inner class. It is nothing but our class extends class loader. It is nothing but custom class loader, right? So here, see, 9 step class loader is a outer class and bootstrap class loader, comma, platform class loader, comma, application class loader, comma, custom class loader are inner class represented by dollar symbol, right? Class loader, dollar symbol, bootstrap class loader, bootstrap application class loader, dollar, application class loader, bootstrap class loader, platform class loader, right? So this is a custom class loader. You can also add if you class loader, dollar, custom class loader, right? This is done. So note, since Java 9 version onward, extension class loader removed and in that place, platform class loader introduced. It is done. 10th point, delegation hierarchy algorithm will delegate request to parent class loader to such dot class file. If not found, the delegation hierarchy algorithm will delegate request to parent class loader to such dot class file. Post it will give priority to parent class loader. See here parent class loader is nothing but bootstrap class loader. So post request is coming to custom class loader, then it will send to application class loader. After that, it will goes to platform class loader. After that, it will goes to bootstrap class loader. If in bootstrap class loader not found, it is so immediately goes to subclass, it will be found, then it will be loaded into method area. So method area, let's do. This is method area, right? Post request is coming to outer class here when in this step. So see, from method area, request goes to class loader to such dot class file, right? So let's do one thing. So about request goes from, so request goes from method area to outer this class loader, right? See, from method area, request goes to class loader to such dot class file. Then class loader sends request to class loader inner classes to such dot class file in various locations by using delegation hierarchy algorithm, right? After that, request is going to these inner classes. So by using delegation hierarchy algorithm, right? By using delegation hierarchy algorithm, do one thing. We can move this to here by using delegation hierarchy algorithm, right? So it is a parent. So it is a child, right? After that, delegation hierarchy algorithm will delegate request to parent class loader to child dot class file. If not found, then immediately suggesting subclasses, right? Suppose it is found at the bootstrap class loader dot class file will be found. Dot class file will be found. Dot class file will be found. Post add here, such as for dot class file, such as for dot class file, increase to 20. So such as for dot class file. Here forward request to forward forward request to, so increase size to 20. Here from here onward forward request to here class loader subsystem to search. Here forwards to inner classes to search dot class file. Forward request to here, request is forwarded to here, so it will be such as dot class file, right? So first it will goes to custom class loader, then it will be forward to it will be reached to bootstrap class loader, right? It will reach to bootstrap class loader. So it will reach to bootstrap class loader, right? First it will search as dot class file. It will search as from here dot class file available or not. If available, if found, then it will be loaded. See, such as for dot class file, such as for dot class file, right? You can add here, do one thing, this one. So such as for dot class file, right? Such as for dot class file. Suppose if found, so if found dot class file, if found, then loaded into, suppose if found loaded into method area, loaded into method area. If found loaded into method area. So increase to 20. If found loaded into method area. So if found then loaded into method area, right? Suppose if found in bootstrap class level, at bootstrap class level it found dot class file, then if found, then loaded into method area, right? So here from method area, request goes to class loader to such dot class file, right? Request. So from method area, request goes to class loader to such dot class file, such dot class file. So if form loaded into method area, right? So where this class loader will such as dot class file in different locations, bootstrap class loader location, platform class loader location, application class loader location, custom class loader location, right? So for that, do one thing, request forwarded, right? So so that it will goes to another request will be there. So here request forward request forwarded to these inner classes. These will be such as in various locations, right? So for that, do one thing, such as in various locations. So increase to font to 20. So this will goes to this will be goes to hard disk. This will be goes to hard disk to such as for the dot class file. So such as for dot class file, such as for dot class file, such as for dot class file, bold 20, right? So roll up such as for dot class file. You can add here. So such as for dot class file, right? Suppose if not found here in bootstrap class order, not found, demo dot class file not found, then it will immediately such as in platform class loader, right? It will be immediately such as in platform class loader, right? So control C, control C, control V, control V, then immediately it will be such as when if not found, it will immediately will be such as. So again will be such as, again will be such as. So when forwards, right? You can add forwards. So here you can add if not found, it will be such as in subclass, right? If not found, it will be such as in subclass. If not found, it will be such as. Again, control C, control V, add here another, control C, control V, if not found, right? Control C, again here, So if not found, Control C again. So if not found, it will be such as in custom class loader. In custom class loader also not found. What will happen if in custom class loader also not found? So for that, do one thing. So if it is not found here also, child, suppose if not found. So in custom class loader also not found, then it will raise the exception. Then it will raise class not found. It will raise class not found exception. Then it will raise class not found exception. It will raise class not found exception. Then it will raise class not found exception. So here, so I'm changing the color. So this is the font color now. Here, then exception will be raised. Exception will be raised like like class not found. Then exception will be raised like class not found exception. Class not found. Class not found exception. So you can add another arrow. So Control C. Do one thing. Decrease the size. Control C. Control V. Rotate. Rotate. Yeah, like then will be raised. Then exception will be raised. Then exception will be raised like then exception will be raised like class not found exception. Then exception will be raised like class not found exception, like class not found exception, right? See, then exception will be raised like class not found exception, class not found exception, class not found exception will be raised, right? Then exception will be raised like class not found exception, class not found exception. See, then exception will be raised like class not found exception. Then exception will be raised like class not found exception, right? Let's check the points. 10th point. Delegation hierarchy algorithm will delegate request to parent class loader to such dot class file. If not found, then immediately search as in sub class loaders. When searching dot class file, priorities are, see, it will be first delegate the request to parent class loader. It is a custom class loader, it is a child class loader. It will delegate to parent class loader, bootstrap class loader. In bootstrap class loader, dot class file not found, then it will delegate to platform class loader. If not found, then it will delegate to application class loader. If not found, it will delegate to custom class loader. It is also, if here also not found, then exception will be raised like class not found exception, right? So we need to add here step 11. Let's add about custom class loader. Why we need? Now add the point A. So delegation hierarchy algorithm will delegate request to parent class loader to such dot class file. If not found, then immediately such as in subclass loaders, right? So here if application not suitable suitable for default default class loader mechanism, then we can create custom class loader, custom create custom class loader, if application is not suitable for default class loader mechanism, then we can create custom class loader, so for this example, how to create custom class loader? Example. So example, open the STS. So launch. So here, just I will show some syntax like that. Public class custom class loader. Public class custom class loader. See, extends class loader. Extends class loader. After that, we need to override one method. So we need to override one method. See, override. This is override method. This method is available in class loader. So this method we need to override protected class colon question mark find class string name here throws class not found exception. We need to implement the logic. We need to add the our choice implementation. Suppose add here implementation code. Add here implementation code. See, if application is not suitable for default class loader mechanism, then we can create our own. Custom class loader. Example, public class, our choice class name, extends class loader. We need to override find class method. We need to pass this string. It is throws class not found exception. We need to add here implementation code. This is done, right? So step 12. Here different, see, such as in various locations, right? We can find out which locations. Boast of class loader, it belongs to which location. We can find out. Class loader, platform class loader, it is related to which packages are related to under class loader, platform class loader, and which packages belongs to application class loader, right? What can I find out? I will explain here. So next, delegation hierarchy algorithm. Delegation hierarchy delegation hierarchy algorithm. Delegation hierarchy algorithm is implemented for giving first priority to predefined classes to search dot class file here. Delegation hierarchy algorithm, this is the right delegation hierarchy algorithm delegation hierarchy algorithm is implemented for giving first priority to predefinite classes to such dot class file. Predefinite classes to such dot class file. Predefinite classes to such dot class file. Right? So predefinite classes to such dot class file. Here delegation hierarchy algorithm is implemented for giving first priority to predefinite classes to such dot class file. Dot class file. Predefinite classes were available. Bootstrap class loader. In this bootstrap class loader, predefinite classes will be available. Here also available. Here also available. But post priority it will give to bootstrap class loader. If not found, it will be goes to platform class loader. If not found, it will be goes to application class loader. Right? So here, so first point here. bootstrap bootstrap class loader bootstrap class loader it is not implemented in Java. It is not implemented in Java. Implemented in native languages like implemented in implemented in native native languages like C, C plus plus, C plus plus, C plus plus. So because of this reason, if we are try to print this class name we will get null. This is important. So bootstrap class loader it is not implemented in Java, implemented in native languages like C, C++. Because of this reason, if we are trying to print this class name, we will get null. I will show one remaining class loaders are added. I will show example platform class loader, platform class loader, platform class loader in Java 9 version. In Java 9 version, extension class loader, extension class loader removed in this place new class loader added is called as platform class loader in Java 9 version extension. Here it is important. In Java 9 version, extension class loader is removed. In this place, new class loader added is called as platform class loader. Third point, application class loader, right? Another name is there. System class loader, or we can also call app class loader or application class loader. System class loader or app class loader or app also nothing but application class loader. Fourth is there custom class loader, class loader, custom class loader, if above these are not sufficient for our requirement, then we need to add custom class loader. So here I am added. If application is not suitable for default class loader mechanism, then we can create our own custom class loader. Then see our class extend class loader, we need to override find class method, then we need to add the implementation code. So here up to I will provide one example. The delegation hierarchy algorithm is implemented for giving first priority to predefined classes to such dot class file bootstrap class loader. It is not implemented in Java, implemented in native languages like C, C++. Because of this reason, if we are trying to imprint this class name, we will get null. Platform class loader in Java 9 version. Extension class loader is removed and in this place new class loader added is called as platform class loader. System class loader also called as application class loader also called as app class loader. Custom class loader example I will show. Here, open the, so remove this code. Some code is there. So remove this one. So let's take one main method. Main method. So main method, right? Select a control shift F for format, pretty printing like that. So modules introduced, right? Java 9 version. Modules introduced, right? Module, module layer. Let's see. Module layer. Layer equal to module layer dot boot. Module, module layer dot see boot. What will do? Return the boot layer. The boot layer consists at least one module. So after Java 9 version onwards, modules are introduced, right? So this one semicolon, then layer dot module, it is a returning set, right? We can use the for each. So suppose take like a module lambda module lambda. You can print the name so system.out.println. Suppose class loader name. Suppose do one thing here. Take this dot get name. Let's check what is printing as of now. Right click, run as Spring Boot application or app. Let's see what is printing. So module layer, by using this module layer, so we can find it which classes are belongs to which packages. See, these are the packages it is showing up to. These are the packages are showing. It is okay, fine. Let's add suppose string class loader name equal to class loader name equal to. So create one class loader object, class loader, create one. The class loader, java.lang, class loader equal to module dot get class loader. See, it is returning class loader for this module, returning the class loader modules nothing but packages, right? Packages. So it will returning the class loader name. So dot, after that dot get name. It is in get name. See, return the name of this class loader or null. If the class loader is not named, the bootstrap class loader is a null. It is not named, right? We will get some nulls as well. So let's class class loader name. Class loader name. So plus symbol, some space, colon. Let's check now what will happen. Right click, run as Spring Boot app. Spring Boot app. See, null pointer exception cannot invoke Java class loader name because class loader is null. Class loader is null. So some error we are getting, see here. So let's check what is happening here. So let's draw the execution engine. So go to step 23, execution, execution engine. Execution engine nothing but so execute bytecode, right? Execute byte. See here dot class code executed by execution engine dot class code executed by execution engine. Step 24. Let's draw a diagram execution engine. So let's draw a diagram. So take this is the one box, copy control V, another box, small one, here also small one. These are the three, right? Move, take another. So after that, see here, after that add, this is the one box to another one. So copy control V, fine. So this is a execution engine. This part is belonging to execution engine. Suppose this part is execution engine. Scroll down. Yeah, this is done, right? Yeah, this is the execution engine. So it is the execution engine. So text execution engine. Execution engine nothing but here execution engine nothing but dot class code executed by dot class code executed, right? So dot class code executed. Dot class code executed, right? So see here. So execution engine dot class code executed 20 execution engine dot class code executed. I am adding here. So this is the post one. It is nothing but interceptor. It is nothing but interceptor. Post add the links. So post add the links. Suppose yeah done. So this is the execution engine dot class code executed, right? It is a interceptor. So it is a interceptor. Interceptor. What is this interceptor? I will explain line by line. Byte code will be executed line by line. So interceptor, it is nothing but interceptor. Here interpreter. In interpreter, here enter interpreter dot class code executed line by line dot class code executed line by line. So execution engine, suppose this is the one red execution engine. It is multiple parts like execution engine contains interpreter inter interpreter jet compiler native method library in jet compiler byte code converted into mission code. Byte code converted into mission code. So here byte code converted into mission code. Jet compiler byte code will be converted into mission code, right? So the interpreter is dot class code executed line by line. Dot class code executed line by line, right? Executed line by line. So 20 here dot class code executed line by line. This is done. Here JIT compiler. JIT means just in time. Add here just in time JIT compiler. JIT compile interpreter class code executed line by line, right? After that step 25 JIT compiler. JIT stands for a JIT. JIT stands for just in time just in time compiler. So here next one intermediate code generator intermediate code generator intermediate code generator will be there here. Second one code optimizer code optimizer will be there. After that code optimizer will be there. Third one target code generator target code generator target code generator. After that this is the C, this is the D, this is the E. Mission code or negative code. Mission code or negative code. Mission code or negative code. See, one by one I will explain. JIT stands for just-in-time compiler. Here, just-in-time compiler, it will be compiles compiles the compiles the here just-in-time compiler compiles the bytecode compiles the bytecode into Mason code bytecode into Mason code compiles the bytecode into Mason code. This is done right. Intermediate code generator. Here intermediate code generator con converts the compiler the bytecode into Mason code, right? It will be converts. Here it will do intermediate code generation, right? Platform independent independent code generator. It will generate the platform independent code. It will generate the platform independent code, right? After that, here code optimizer is nothing but improves improves performance improves performance target code. It is nothing but mission code. It is nothing but mission code. So native code are native mission code are native code. Mission code are here. Mission code are native code is nothing but final executable code. Final executable code. So let's add one by one. Git compiler, right? Let's see. This interpreter is done, right? Next, after interpreter, git compiler, right? So here, git compiler, add git compiler, what it will do. So here, compile the bytecode into mission code. Compiles the bytecode into mission code, right? Compile the bytecode into mission code. So this time take 18 undo one thing, decrease this one, control Z, control Z. Yeah, this is sufficient, but this require more. This is the jet compiler, compile the bytecode into mission code. After this done, this is the post one. Here, control Z, control Z. So take here, so rubber, control Z, control C, control V, add here. So jet compiler, compile the bytecode into mission code. This is the done. Next one, intermediate code generator, platform independent code generator. So it is nothing but platform independent code. Copy this one, control C, another text box, select a bold, increase size to 20, right? So here it is 18, so decrease size to 18. After that, copy, control V, platform independent code is ready. Then code optimizer, improve performance. Git compiler also improve the performance. This is Azure. code optimizer, improve the performance. So text, control V, select all, bold, 18. So here, code optimizer. This is done. Next, control C, control V. After that, target code generator. It is nothing but mission code. It is nothing but mission code. Scroll down. Scroll down. So increase. Next one. Next text box. Target code generator. Target code generator. Nothing but mission code. So bold 18. 18. It is done. Next. Here mission code or native code. It is nothing but final executable code. It is nothing but final executable code. So test. Here bold 18. It is a final executable code. So copy, control V. It is mission code or native code, final executable code. It is ready, right? So interactions between these two, like control C, control V. Okay, fine. Yeah. So interpreter, we are understand, right? Dot class code executed line by line. Jet compiler, just in time compiler. So it will help to improve the performance, right? See, these are the steps are there in Jet compiler. Compile the bytecode into mission code. It will do. After that, intermediate code generator. It will do. Platform independent code. Code optimizer. It will help to improve the performance. Target code generator. It is nothing but mission code. Mission code or native code. It is nothing but final executable code. Final executable code. So I will explain about these two boxes as well. After that, we will need zip compiler, just-in-time compiler to improve the performance. To improve the performance by using like profiler and hotspots and code optimizer multiple. It will take helps from multiple like profile, hotspots, etc. It will improve the performance. Performance here, here. Overall, Git compiler will do the steps. The out of the 5 steps will do bytecode converted into converted bytecode converted into OS converted into mission code converted into mission code just in time compiler bytecode converted into mission code. JIT will do convert bytecode into mission code. That's it. These are the 5 steps will done. It will also improve the performance by using profilers, right? So here next step 26. Step number 26. Hotspot profiler. Hotspot hotspot profiler. Hotspot profiler. Hotspot profiler. What is this? This will help to Git compiler to improve the performance. How? I will show. How will here hotspot profiler? It will identify identify whether this method repeatedly repeatedly require compiler is called repeatedly See, hotspot profiler, it will identify whether this method repeatedly called or not. If called, it will not load again. Like this method, this it will identify whether this method repeated. Here, it will identify whether this method repeatedly executed. If it is repeatedly executing, then it will again and again, it will not convert bytecode into machine code. It will convert only one time only. It will identify whether this method or this code repeatedly executed, or it will identify whether this code repeatedly executed. It is nothing but hotspot profiler. Hotspot profiler. Let's add the text. So hotspot profiler here. So select all, bold, increase size to 18. So see here, hotspot profiler. It is nothing but hotspot profiler. It is nothing but here. It will identify whether this code repeatedly executed. This code repeatedly executed. This code repeatedly executed. Right? Hotspot profiler. It will help. Hotspot profiler will help to JIT compiler to identify whether this code is repeatedly executed or not. It is repeatedly executed, then it will not convert again and again to the bytecode to machine code, right? So add this one here. Otherwise, copy this one. Control C, Control V. This is the done. Next one. So let's check next one. This is the security manager. So this is the security manager. Copy this one. So text box, it is a security manager. It will some security policy will be there, like input output operations. It will check security. This is the security manager. After that, garbage collector, nothing but cleaning activity. Once our class is successfully completed, execution, then it will be destroy the objects, right? It will be cleanup activities. Next one is the garbage collector. Garbage collector. Garbage garbage collector. Garbage collector, nothing but some cleanup activities. 18. Garbage collector. So it is done. So now successfully execution engine is done. Execution engine is connected into native library. So I will explain that. So next one, native Java native interface. Java native interface. Before copy this, Control C, Control V. Add here another Control V. Add here. So see various runtime areas or memory areas connected with execution engine. Remember, connected with execution engine. So now it is a native method library. It is a native method library. By using this, we can call the native code. This native code implemented in native languages like C, C++. Here, native method library. Native method library. Native method library. This is the native method library 20. So it is a Java native interface. It is a Java native interface. Java native interface. It is a Java native interface. Copy this one. This is Java native interface. So arrow marks add. See, in our code we are added one sleep method, native method that have no body, right? By using like native library, it will call the native languages like C, C++. Java native interface, JNR. Here you can add straight away here. So Java native interface, it is nothing but JNR, JNRI, Java native interface, JNI. So it is the entire architecture of JVM. This is the JVM architecture. So let's change to Java virtual, Java virtual machine. So expand. This is the Java virtual machine. Right. This is the Java virtual machine. So draw the complete border. Now I am adding complete border for this diagram. Yes, after that, I will add another point about the Java native library, JNI. So scroll down. Control Z. Share. So next, scroll down. Scroll down. So JVM is completely three parts. First one is cross-loader subsystem. Second one is various runtime areas or memory areas. Third one, execution engine. Third one is execution engine. Here. So this is the entire JVM architecture. So this is the most important for freshers. Mostly they will ask memory areas like method area, heap area, Java stacks area, PC register. PC stands for program counter, native method stacks. These are the important. So diagram is done. Let's verify. Java virtual machine. If you want to add anything in bracket, add here. Suppose JVM, Java virtual machine. Here, scroll down. So scroll down. Native, Java native interface, right? So Java native interface, I will add here one point. I will add one point. So text Java native interface is responsible for responsible for responsible for native methods responsible to provide is responsible to provide native methods information is responsible to provide native methods native methods information. For example, native methods information, for example, sleep. Select bold, change to 18, right? Is responsible to provide native methods information. Example, sleep method only have declaration. Se- Sleep method only have declaration. There is no implementation in Java. Is responsibility to provide native methods information. Is responsibility to Java native interface. Java native interface is responsibility to provide native methods information. Example, sleep. Last add. This is the final step. 26 done, right? 28th, 27th step. 27th, 27th Java native interface. Java native interface. JNI. JNI. Java native interface. JNI. Point number A is responsibility to provide native methods information. Is responsible responsible to provide native methods information is responsible to provide native methods information. Example, sleep method, wait method, sleep sleep method sleep method, wait method, wait method, wait method, etc. Here Java native interface JNA to responsible to provide native methods information. Example, sleep method, comma, wait method, comma, etc. Sleep method, comma, wait method, comma, etc. The another point in interpreter. This is most important point. Class code executed line by line, right? Class code executed line by line. If any runtime errors, errors, errors are errors are occur, then these errors found found at interpreter at here only interpreter. If any runtime errors are occur, then these errors found at interpreter at interpreter at interpreter. Examples examples arithmetic exception, arithmetic 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 exception, null pointer exception, null pointer exception, null pointer exception, etc. The arithmetic exception, null pointer exception, etc. These errors are found at interpreter level while executing the bytecode only. Runtime errors are found at execution engine level, inside execution like interpreter level. So runtime 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 errors found at interpreter level, interpreter level, right? Next year go to Java native interface. JNI is responsible to provide native methods information. Example, sleep method, comma, wait method, comma, etc. Here native method. What is native method? We need to understand what is native method. Here it is important. What is native method? A method with native keyword, comma, a method that have have only declaration in Java programming, only declaration Java programming with native keyword and its implementation logic is connected with connected to C++ programming program. Then that method is called as native method. That method is called as native methods here. A method with native keyword, comma, a method that have only declaration in Java programming and here a method with native keyword, comma, a method with native keyword, comma, that have only declaration in Java programming and its implementation logic is connected to C++ programming. Then that method is called as native method. Then that method is called as native method. Right? Let's let's discuss some of the interview questions. If any points are missed, let's cover it. So up to this 27 points completed. So if anything is missed, let's cover in interview questions. First one, what is JVM? What is JVM? Answer is here. What is JVM? These are the important interview questions. What is JVM? JVM stands for Java Virtual Machine. JVM JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. JVM is part of JDK. JVM is part of JDK. JVM is part of JDK. JVM is a process-based virtual machine. JVM is a process-based virtual machine. Process-based virtual machine. JVM is a process-based virtual machine. If you want to add the point A, JVM stands for Java Virtual Machine. B, JVM is part of JDK. C, JVM is a process-based virtual machine. So, fourth point, JVM as the JVM, JVM as the responsibility. JVM as the responsibility of search, if found, load, allocate memory, and execute the Java dot class file line by line line by line. What is JVM? JVM stands for Java Virtual Machine. JVM is part of JDK. JVM is a process-based virtual machine. JVM has the responsibility of search, find, load, allocate memory, and execute the Java class file line by line. Java class file line by line. Here, second interview question. Types of class loaders in JVM. Types of class loaders in JVM. Types of class loaders in JVM. So there are three types. First one is the bootstrap class loader. Bootstrap class loader. Bootstrap class loader. Second one is the platform class loader. Platform class loader. Another one is the app class loader or application class loader. App class loader. It is covered. Third one, let's check as of now. Types of class loaders in JVM. Class loader, post add, class loader work is such as for dot class file. If found, if found, if found, loaded into method area. If found, loaded into method area. This is right. Next question. First, go to the diagram. Scroll up here. This is the loading. Loading contains class load types of class loaders in Java. This class loader is a outer class. These are the inner classes, right? Bootstrap class loader, platform class loader, app class loader. You can also add another point here. Fourth point, custom custom class loader. Custom class loader. Custom class loader also there, right? Next one. This is the done. Next one. Plus some changes required. So instead of this word, change to here. Scroll down. Yes, this is the correct. So next question. Why parent delegation hierarchy algorithm is implemented? Why delegation hierarchy algorithm implemented? Delegation 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 hierarchy algorithm is implemented. Why hierarchy algorithm is implemented. Why delegation hierarchy algorithm is implemented? Answer is answer is giving giving answer is giving first priority to predefined classes to load into JVM. Why delegation hierarchy algorithm is implemented? Giving first priority to predefined classes to load into JVM. Next question. Here, next question. What is JIT compiler in JVM? What is JIT compiler in JVM? What is JIT compiler in JVM? Answer is compiler compiler translates bytecode into meson code at runtime. Execution engine invoke at runtime only, right? Every, I think, three parts. JVM contain three parts, right? Class loader, subsystem, various memory areas or runtime areas. Execution engine, both three are involved at the time of runtime only. Here, what is JIT compiler in JVM? Compiler translate bytecode into mission code at runtime. It will just translate the bytecode into mission code. To improve the performance, it will use as the hotspot profilers. Then another question. Here, next question. How many runtime areas? How many runtime areas are memory runtime areas are memory areas in Java. Some people they will ask like in Java, or some people they will ask like in JVM. See, how many runtime areas are how many memory areas in Java or JVM? Someone will ask Java, someone will ask like a JVM in interviews, like I am attending recently one interview. They will ask like how many memory areas in Java. Sometimes they will ask how many runtime areas in JVM. Again, they will ask how many runtime areas in JVM. They will ask, they will some person they will ask in Java. How many runtime areas in Java, like that. So here There are 5 are there. Method area. It is responsible to load it will be loaded the dot class file. Class loader subsystem is responsible to find the class and load it into method area. So this method area, static blocks methods will be there available. So post static variables stored with default values. After that, while initialization phase, it will default value replace it with original values. This is right. Method area, heap area, heap heap area is nothing but so heap area. Here objects will be created, right? So let's add. I have not added anything about heap area. Let's add heap area here. Heap area objects will be created here. Otherwise stores objects. Here objects will be stored. Here stores objects. Here stores objects. Objects comma instance variables. Instance variables as well. Stores objects comma instance variables. Next Java stacks. Third one is the Java tags. Java stacks. It is nothing but it will execute the method calls and here available method calls method calls logics executed method calls and logics executed method calls and logics executed method calls and logics executed method calls logics executed, right? Next one, fourth one, PC register PC register PC PC register PC register. Let's go to top. Let's check where I added anything. PC register. PC stands for program counter. We are not added. Yeah. PC register. One pair thread. Each thread instructions to be executed. One pair thread. Here it is for one pair thread. One pair thread. One pair thread. One pair thread. Each thread instructions to be executed to be executed to be executed to be executed. Here one pair thread, each thread instructions to be executed, each thread instructions to be executed, each thread instructions to be executed. One pair thread, each thread instructions to be executed. Negative method stacks. Here this is the fifth one. Negative method stacks. It will store negative methods. It will store negative methods. Here negative method stacks. It is nothing but supports executing negative methods implemented in languages like C, C++, C++, C++. Supports executing native methods implemented in C, C++. So next question is Java 9 version changes in JVM. Java 9 version changes in JVM. There are 2 points are there. rt.jar class file classes rt.jar file classes moved to different modules in Java 9 version, in Java 9 version. So Java 9 version changes in JVM. rt.jar file classes moved to different modules in Java 9 version. See here, these modules were verified, right? At the time of, this is the class loaders. At the time of step 12, at the step of 12, where by using module layer, this is the class loader class where verified modules, right? Java 9 version changes in JVM. rt.jar file. Jar file classes moved to different modules in Java 9 version. In Java 9 version, rt.jar file classes moved to different modules in Java 9 version. In Java 9 version, this is the one. After that, in Java 9, in Java 9, in Java 9 version, extension class loader, extension, class loader, removed in this place, new new class loader, added, 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 added is called as platform class loader is called as platform class loader is called platform class loader. Java 9 version changes in JVM. This is important. Java 9 version changes in JVM. rt.jar file classes move it to different modules in Java 9 version. In Java 9 version, extension class loader removed in this place. New class loader added is called as platform class loader. Is called as platform class loader. Is called as platform class loader. Another question. Next question. Where where static variables loaded in JVM? Where static variables loaded in JVM? Answer is method area. Method area. Method area. Method area. See here, we are stored one static variable, right? This is the static variables. It will be stored at the method area, right? Next one, next question. Where objects will be created in JVM? Where objects will be created in JVM? Where objects will be created in JVM? Answer is where objects will be created in JVM. Answer is heap area. Heap area. Next interview question. See, heap area stores objects or creates objects. So either we are storing or creating objects here. Storing objects or creating objects, instance variables. This is done, right? Next question. Here, next question. What will happen if what will happen if dot class file not found in or class loaders or class loaders or class loaders? What will happen if dot class file not found in all class loaders? What will happen? We will get the class not found exception. We will get class not found exception. We will get class not found exception. Another interview question. So let's improve the diagram post. This is the method area, class file loaded, class level metadata. This class level metadata here is available at, for class level metadata we have meta space is there, meta space will be there. So meta space static blocks will be executed from top to bottom, right? Here static variables allocated memory with default value. After that, replace it with original values, right? Stores class metadata method area stores class stores class metadata starting with Java 8 metaspace replaced with firm space class level data. Here available. Add the text box here. Text box class level data available. Here class level metadata or class level data available. Static variables, constants, static variables, static variables, static variables, constants, 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 method definitions, method definitions, runtime constant pool, runtime runtime constant pool will be available here. Here will be available here. Static variables, constants, method definitions, and runtime constant pool, increasing size. Here these are the available static variables, constants, method definitions, runtime constant pool. These are the available. This is class, right? Class contains class members, like class members, nothing but here. Suppose class, suppose class demo, right? Class demo contains members like private, private members like private, static. Suppose a equal to 10, and private, 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 static, integer, private string, private, private string, name equal to method calls. Suppose public void, public, public, public string get data. This is the one method. Like this will be there. Like this will be there. So this is the class. This is the one class, right? Control C, Control V, decrease the size to. This is the demo class, right? This is the done method area. Method area nothing but dot class file loaded. Class level metadata. We have a meta space as well there. Class dot for name. So class name dot class name dot name. Static blocks will be executed from top to bottom. Static variables, constants, method definitions, runtime, constant pool. This is done. Here, app area. So see one for JVM. So both two for JVM. JVM is dot class. Each dot class one JVM will be created, right? Stores objects, creates objects, instance variables. Nothing but here add. Suppose creates objects, right? Demo, demo, demo equal to new demo. I'm created one object. So I want to initialize. I want to initialize one instance variable value. Suppose B is a instance variable, then demo dot b is equal to suppose 30 initialization like this. So bold, this kind of logics we can add here. We can create objects, we can initialize the values for instance variables. This is done after stack area. Here next Java stacks method calls. Here method calls will be there. After that method calls local variables. So change this one. Method calls will be here. Local variables, method calls and local variables. You can mention like method calls, local variables. So like each method call it will be one Java stack frame will be there. It is three parts. Local variables, apparent, like three parts will be there. Stack frame will be three parts. So remember, if you want to, I can add stack frame. Stack frame will be three parts. Like assume this is a stack frame. It is a three parts. Control C, Control V. It is a stack frame. So test stack frame. Stack frame contains three parts. So maximize to 18. After that, this is the stack frame. So this is it done. After that, program counter register. Program counter. See here, one pair thread. Each thread instructions to be executed. Instructions being executed for that thread. Executed. Executed spelling wrong. Let's change. Executed. This is when one pair thread. Each thread instructions to be executed. It is next interview question. It is a final interview question. Order of Java program execution. Order of Java program execution. Order of Java program execution. This is very important. Very important. So post one. So execution order from static blocks. Execution order from static blocks. Post static blocks will be executed at the method area. After that, objects creation in Java stacks, and after that, objects creation in Java stacks, and local variables created in Java stacks. Local variable created in Java stacks. Here, execution order from static blocks. This is static blocks executed at method area. Objects creation in Java stacks, and local variables creation in Java stacks. Right? Here, assume this is a C. So execution order from static blocks. After that, the main method loaded and executed into Java stacks. Then main method loaded and executed into Java stacks. Third one, objects creation in Java stacks and local variables creation in Java stacks. Here, execution order from static blocks, then main method loaded and executed into Java stacks. Objects creation in heap area and local variables created in Java stacks. Constructor called then local variables default values replaced with original values. See, constructor called at Java stacks. So let's open our class. Let's understand here. This is the class, right? Double click, it will open. So post, this is the static variable, it will be loaded at method area. This is the non-static, it will be loaded at Java stacks. This is the constructor loaded at method area. This is the non-static. This is the static block, it is loaded at the method area. This is non-static block, it will be invoked at the time of object creation only. Then object creation done at the heap area, right? Object creation done at the heap area. So it will be called heap area. Public static main method called at the Java stacks. Objects creation done at Java stacks only, but it is pointing to heap area. Inside heap area, it is storing. Heap area inside storing. Then static methods, method called done at Java stacks only, but it will be stored into heap area. So done. So in this video, we have successfully understand JVM architecture. It has three parts: class loader subsystem, post part. After that, various runtime areas are memory areas. After that, execution engine, class loader subsystem will load the .class file. After that, runtime areas will allocate the memory. After that, execution engine bytecode converted into mission code. Thank you for watching. For more videos, please subscribe to this YouTube channel.